Welcome to Gumber's Mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
We are going to learn about graphical method of solution of a pair of linear equation. I hope you all have gone through the first video, which was related to the introductory part of pair of linear equation, how to frame the equations, how to write the equations in algebraical form, and how to find the graph of the given equation. This we have discussed in our previous video, that is introduction of pair of linear equations. Now we will be finding the solutions of these pair of linear equation with the help of graphical methods. Let's try to recall. As we have learned that the linear equation in two variables has a graph as straight line, and if we are taking pair of linear equation, it means we are considering two lines. The two lines in a plane can be of three types. Three situations are there of the possibilities. One is the lines can be intersecting, or it can be parallel, or it can be coincident lines. So if intersecting lines are there, it means this is the point which is the solution of first equation as well as the solution of second equation. It means this is the point which is having one and only one solution. Therefore, it is also known by the name unique solution situation. Now, if two lines are parallel, it means there is no common solution. It means they are having their own ways of explanation. They are not listening to each other, and therefore, whenever someone is not listening to other, therefore that case there is no solution for that problem. Now, if they both are taking care of each and other, then they are listening to each other, and how many common solution would be there in that case? There would be infinite many solution. Each and every solution which is the solution of first equation is also the solution of the second equation. These type of lines are called coincident lines if these are overlapping each other. Next is a pair of linear equation which has no solution. Lines are parallel. This is called by the name inconsistent pair of linear equation, which is no solution type situation. The lines are parallel. Now, if the linear pair of two variables which has a solution, that is called consistent, means they are having some solution. There is a solution for this problem. Now, third is a pair of linear equation which are equivalent to each other, completely multiple of each other, has infinitely many distinct common solutions. Such a pair is called dependent pair. Why? Because it is having infinite many solutions, and these solutions can be written in the form of dependency of one variable upon the other variable. We will be going through this linear equation in two variables. A dependent pair of linear equation is also consistent because there is also a solution. From here we can conclude that whatever problem is having a solution, that is consistent, whether it is having a single solution or it is having infinitely many solutions, that is consistent. And if it is having no solution, it means this is inconsistent. Now try to understand the things again as a summary. The lines which may intersect at a single point are having unique solution, are consistent pair of equation. The lines which are parallel to each other, they are having no solution situation, and these are also inconsistent pair of linear equation. Next is a lines which are coincident, overlapping each other. In this case, we'll be having infinitely many solutions, and these type of solutions are dependent solutions, and this is consistent pair of equation. Now let's see the relation. This we observed in first video also. Now we are going to recall this. These are the three equations that we have considered in example number 1. This was in example number 2. This was considered in example number 3. If we compare these, the coefficient of these, we can coefficient of the variables, we can see that here we are writing a1 upon a2, b1 upon b2, c1 upon c2. Let's see, is there any relation? Then what kind of solution we are getting? If we observe first case, this is 1 by 3, this is minus 2 by 4, this is 0 by minus 20. Here we can see that a1 upon a2 is not equal to b2. And in first example, we got the graph as intersecting lines, which says exactly one solution. And if you observe the example second, in that we were having equivalent equations which are equivalent to each other. Completely the multiple of each and every term is multiplied by 2 to get the second equation. Now we can see the ratio of their coefficients 1 upon 2, here also 1 upon 2, here also 1 upon 2. It means these are equivalent equations, and we can see a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. If the equations are of equivalent type, these will overlap each other, these will be getting coincident lines, and it will be having infinitely many solutions. Now third example, here we can see the coefficient of x is 1 and 2, 1 by 2, and here 2 by 4, that is also 1 by 2, and if we'll observe these, we'll be getting 1 by 3. Here we can see that a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. They are ready to listen each other, but the third person is not ready to listen, so therefore these are parallel. There would be no, if they will not listen to each other, they don't want to compromise, they will not get any solution. No solution. They are just going to their own paths, therefore no common solution would be there. Now again, let's try to recall these things. Intersecting lines, it means unique solution when a1 upon a2 is not equal to b1 upon b2. Coincidence line, many solutions when these are equivalent to each other, means with the same they are getting multiplied to get the second equation. Next is parallel, if they try to listen but nobody is listening to them. This means a1 upon a2 is equal to b1 upon b2 but c1 upon c2 is not equal, then the lines are parallel and will be getting no common solution. Therefore, no solution of this pair of linear equation. Let's try to do example number 4 from NCERT. Check whether the pair of linear equation is consistent, means solution exists or not. If solution exists, then solve it graphically. Let's see very first. For this consistent or inconsistent, we need to find the ratio of the coefficients. Now a1 upon a2 is equal to coefficient of x means 1 upon 2. Okay. b1 upon b2 is equal to plus 3 upon minus 3, that is equal to minus 1. a1 upon a2 is not equal to b1 upon b2. Therefore, we can say that it has unique solution. Unique solution. It means it is consistent. So for this we'll be drawing the graph. Let's see. Similarly, we can draw the graph. You have to plot the very first. You have to draw a table, collect the values. So you'll be finding the solutions. Let us again very first equation. For x is equal to 6 minus 3y. Put the value of y is equal to very first 0, we will be getting the value of x as 6. Put y is equal to 1, we will be getting x is equal to 3. Y is equal to 2, we will be getting x is equal to 0. Similarly, you can solve for second, you can find the points for second equation, x and y. Here x is equal to 12 plus 3y divided by 2. Now put the value of y is equal to 0, we will be getting x is equal to 6. Y is equal to 2, then it would be 12 plus 6, 18, that is 9. Let us consider value of y is equal to minus 2. Minus 2 means 6. 12 minus 6, 6. 6 by 2, that is equal to 3. This way, as many as you want to, but maximum 3 you should find. If you are very good at calculation, there is no need to find the third point even, and you can plot the graphs. You can see that here we observed it is consistent. It will be having unique solution, and its graph also shows that it is having unique solution, that is 6 and 0. X is equal to 6 and y is equal to 0 is the common solution. It is having unique solution and the solution is 6, 0. Let's go to next. Graphically find whether the pair of linear equation has solution, no solution, unique solution or infinitely many. Before going to solution graphically, let's try to enjoy that and break up the surprise whether it would be having which kind of solution. Let's see. So we'll be comparing the coefficients. A1 upon A2 is equal to 5 upon 3. Okay. Now B1 upon B2 is equal to minus 8 upon minus 24 upon 5. Now this is equal to minus 8 upon minus 25 into 5, and it will give us 5 by 3. Oh, we have got here A1 upon A2 is equal to B1 upon B2. Let's see, is it holds for C1 also. C1 upon C2 is equal to, C1 is 1 and C2 is 3 by 5. This will be equal to 5 by 3. Aha! It means A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. It means it would be having infinitely many solutions. Now this you have checked. Whether you want to check it or not, they are not asking for this. They are just saying to find the graphically. So let's plot the graph for this. So you can see that you will be getting the same point. So you can have this also. Let's find the point. I hope you can find it yourself now. X is equal to minus 1 plus 8y divided by 5. And you can put here the value of y. Put the value of y as let us consider 2. Y is equal to 2. 8 2s are 16 minus 1 is equal to 15. 15 means 15 by 5, that is equal to 3. So this way you can find the points and you can plot the points also. Now next is example number 6. Champa went to a sale to purchase some pants and shirts. When her friend asked her how many pants she has bought, she answered like that. Yeah, she is very smart. She is not responding like this. She's just just telling her in the form of a puzzle. Let's see what are the words she is using. The number of skirts is 2 less than twice the number of pants. Okay, as well as the number of skirts is 4 less than the 4 times the number of pants she purchased. Okay, help her friend to find out how many pants and skirts Champa bought. So what we can do, we can very first let Champa bought X pants and Y shirts. Then what is the relation given to us? The number of skirts. Number of skirts means Y. Y is equal to, Y is 2 less than whom? Twice the number of pants. How many she purchased pants? X. So twice of that, it means 2x minus 2. And it can be rewritten as 2x minus y minus 2 is equal to 0. And next is second situation. Again, it's also given to us. The number of skirts is 4 less. Again, number of skirts. Skirts means y. Y is equal to 4 less than 4 times she purchased the pant. She purchased X pants. The number is 4 less than the 4 times. It can be rewritten as 4x minus y minus 4 is equal to 0. Very first we can find what is the relation. This is 1 by 2 and here also this is equal to 1. Coefficient relation. The 1 by 2 is not equal to 1 means A1 upon A2 is not equal to B1 upon B2. Therefore it is having unique solution. So we can plot the graph for this. Plotting the graph and it must have unique solution. Let's see. Yes, it is having a unique solution and the solution is so smart. She just purchased X is equal to 1 and Y is equal to 0. And she just rolled her friend in such a big problem to find that. And she purchased how many pants she purchased? X was 1 and Y was 0. She purchased 1 pant and no shirt. skirt. She purchased no skirt for that. This is your final answer. I hope it's clear. Now you can try exercise 3.